In this video, we'll be creating a corridor mass haul analysis using Business Center Heavy Construction Edition. A corridor mass haul analysis can help determine the most efficient way to redistribute earthen material along a corridor construction project. For this example, we have a finish level model of a 5K section of new road that was created using 12D, which we've imported into BC-HCE. As you can see, there are a number of conflicts due to crossing break lines that will need to be resolved before we can create our mass haul analysis. After we've resolved all the conflicts, we can create our subgrade model that can be used for machine control and also our mass haul. Once we completed the finished level model, we were able to generate a subgrade model to use for machine control and our mass haul. Here are the surfaces we will be using in this video: the truck rest area, the off-ramp, the on-ramp, the main alignment, the eastern borrow pit, the Gowrie Junction borrow pit, the western borrow pit, Gansers Road, and the natural surface. First, we created the mass haul corridor using the main alignment. We used the natural surface as the original ground. We limited the extents of the corridor by creating a template at the start and end of the alignment. The surface instruction was used to model the subgrade of the main alignment, and the cross-section view displayed areas of cut and fill from the natural surface. We used a null template at the end of the corridor to limit the extents of the mass haul. Next, we ran the mass haul analysis along the corridor that was just created. A sample interval of 10 meters was used and the earthworks capacities were respected. We then created the 3 borrow pits. A surface-to-surface earthworks report was run against the natural surface to determine the amount of excess material available at each borrow site. Next, the haul roads were created. At this stage, we don't know the haul costs, so $1 was used for each road. We created the haul roads to intersect the alignments at a section where there was a transition between a cut and a fill. A haul road was also created to connect the on and off ramps to the corridor. We then converted the ramps to haul roads so that the west and east borrow pits were connected to the main alignment. An import had to be created at Gansers Road to force material to the site. To do this, we selected a suitable chainage along the main alignment that transitioned from a cut to a fill. An earthworks report was run to determine the amount of material that was needed to be imported to the site. Exports were created for the on-ramp, off-ramp and truck rest area. The change where the exports were to take place was at the ramp connecting these two roads to the main alignment. Earthworks reports were run at each site against the natural surface to define the amount of excess materials. Next, the haul ranges were created. We use a truck with a haul range of 5,000 metres and a scraper with a haul range of 1,000 metres. We then opened the mass haul diagram and refreshed the analysis. The diagram shows instantaneous cuts and fills as well as the location of the borrow pits, the exports and the imports. The auto balance function was then used to balance the haul ranges of the truck and scraper along the corridor. Finally, a mass haul report was created to view a textual representation of the mass haul diagram. Here is a formatted version of the report which shows you both the accumulated and instantaneous volumes at 10-metre change intervals along the alignment. Over the past 2 months, machines on this project have been reporting into Trimble Vision Link recording real-time coverage data. Using Business Center in conjunction with Vision Link, we are able to import this survey data and rerun the mass haul using the current surface. The first step we took to import the Vision Link data was to create a machine data overlay. The overlay type was an elevation and a boundary was used to reduce the amount of data needed to be brought into the model. The project extents were used for the time range. Once the overlay was created, we then were able to create the surface. The mass haul corridor was updated by changing the original ground to the overlay surface. Next, the earthworks quantities required updating, as material has been hauled since the original mass haul was completed. We used the mass haul editor to update these quantities by running a surface-to-surface earthworks report for each of the borrow pits, imports and exports against the overlay surface. From inspection of the truck rest area, we can see that there is a constant depth below the finish level surface. We had this confirmed by the site engineers who informed us that the truck rest area has been completed to subgrade level and is ready for the finish level pavement. We were able to update the truck rest area to a volume of 0 as no further export is required. We could then refresh the mass haul and again auto balance the haul ranges. Finally, the report was run to view the updated earthworks quantities. There was a revision to the design which included additional sedimentation basins throughout the project. Therefore, we updated the corridor mass haul to include these basins. The first step involved was to find whether each individual basin required an import or an export. A surface-to-surface earthworks report was run against the overlay surface to determine these quantities. We created a list of each of the basins and determined from the excess volumes whether they needed an import or an export. Next, we created the haul roads. Each road connected to either the main alignment or one of the ramps. The roads were connected at a transition between a cut and a fill where possible. These roads were for visualization purposes, as when creating an import or an export, the change is determined off the main alignment. As an overpass was to be built over Gowrie Junction, a haul road needed to be created to circumvent this section of the road. It was also used to visualize hauling material past from the northern said basins. A barrier also needed to be created at the center of this overpass to force excess material along the newly created haul road. The imports and exports for the said basins were next created. The corridor mass haul was refreshed and the mass haul diagram reviewed. A number of elements can be seen in the diagram. Material is being hauled along the newly created haul road, shown by the instantaneous drop in usable material at the haul road entry. This material is imported further along the corridor where the haul road connects to the main alignment. The Gowrie Junction borrow pit is not required to be borrowed from, as refreshing the analysis did not show a borrow pit icon on the diagram. The corridor mass haul was then balanced. A mass haul report was again created to view a textual representation of the updated mass haul diagram. By continuing to use Business Center with VisionLink, we can update the mass haul regularly and find the optimum way to haul material throughout the construction phase.